You're a seismologist working at a geological observatory. In the morning, you check the equipment that monitors seismic activity and adjust the instruments. Then you inspect the movements of tectonic plates. Suddenly, one of the devices shows a strange signal. It's like a small earthquake. You make a record of this push and continue working, but the signal repeats again. A little time passes and the devices fix it for the third time. You understand that this is not an earthquake because the signal is too weak for this. It repeats every 26 seconds and resembles a pulse. The human heart pulses close to the center of the chest. The pulse of the planet also comes from its center, the equator. You call other specialists and tell them about the unusual phenomenon, but no one knows what it is. Also, you can't determine the source of the pulse. You arrive at the place where the vibration comes from and find nothing. The ground still pulses under your feet, but it's impossible to figure out the reason. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, but scientists around the world still don't know the nature of this phenomenon. It looks as if our planet has a heart hidden inside its crust, beating every 26 seconds. According to researchers, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea. This area is called the Bight of Bonny. Every winter, the pulse becomes stronger. Then it weakens again by the summer. When scientists began exploring this place, they put forward a theory that the ocean could create the pulse. Waves hit the continental shelf of the planet. That impact deforms the ocean floor. A human hand hitting a table works on the same principle. Sit on one side of the table and put your hands on it. Let someone else hit the table from the opposite side. You will feel a vibration. Ocean waves hitting the coastline create a similar effect. Someone may object that there are waves all over the world, not only at the equator. Yes, but that's where the sun heats our planet the most. Solar energy causes powerful storms and winds and accelerates ocean currents and waves. Also, in 1980, geologists found out that Earth's tremors became stronger during storms. In other words, when waves hit the shore with more power. Not all scientists agreed with this theory. Some researchers believed the planet was pulsating because of the seismic activity. It was coming from a volcano located on one of the islands in the Bight of Bonny. The place where the pulse was the strongest is close to the volcano. But further observations showed that the Earth's tremors happened in all parts of the Gulf of Guinea. That's why scientists can't prove any of these theories. Our planet pulsates not only from within. Earth is surrounded by a thin luminous halo. It's constantly changing its shape and shimmering with different colors. If you look at our planet using special equipment, you'll see that Earth is inside an uneven pulsating bubble. It's located at an altitude of 50 to 400 miles above Earth's surface. This bubble is called the ionosphere. That's a layer of charged particles that separates the upper atmosphere from space. In other words, this is the boundary that sets apart the region where you can still breathe and a complete vacuum of space. The International Space Station travels inside the ionosphere. Most of our satellites also move within the borders of the pulsating bubble. This natural phenomenon can both help and disrupt the operations of communication and navigation systems. It helps radio and GPS signals to get to our mobile phones, but it can also interrupt the stable connection. It all depends on the number and density of charged particles. Sunlight takes away 1 or 2 electrons from the gases surrounding our planet, and they become charged particles. These particles make up the ionosphere. It's constantly changing its shape and size. It happens because the planet rotates around its axis, and the sunlight falls on it unevenly. During the day, the ionosphere is always larger than at night. Because of this pattern, it's pulsating and constantly moving. This instability shortens the life of orbiting satellites and often puts them out of work. Radio and GPS signals pass through the ionosphere and get reflected from charged particles. Then, they fly further to their destination, to phones, navigators, and other devices with GPS and radio receivers. Our planet is not only pulsating, but also buzzing. The noise that Earth produces is called the hum. It's impossible to record this sound, but even so, 2 to 4% of people on the planet hear it. All over the world, people who aren't connected in any way speak about a weird buzzing sound. It interrupts their sleep and doesn't let them concentrate. This noise follows them everywhere. Perhaps you also hear it but don't pay attention. But once you notice the hum, you won't be able to unhear it. Some residents of a small village in Scotland describe this humming as a thick, low-frequency sound. There's a website on the internet with a map where people all over the world register and describe this mysterious noise. Almost everywhere, it's a low-frequency vibration, barely perceptible to the human ear. Sometimes, people say it resembles the noise of an airplane flying overhead, but quieter. Some people describe it as the sound of a running truck engine placed in the backyard. It's humming in the street when they come home. And it gets louder when they are lying in bed. If you hear it too, you can mark it on the map. There are records dating back to the 19th century that describe a sound similar to the hum. But for the first time, the media started talking about this phenomenon in the 1970s in England. Since then, many theories have been made by scientists and people who try to catch the hum. There is a hypothesis that claims the noise comes from high-speed traffic on highways, or it might be caused by too many airplanes flying in the sky. The hum and vibrations can be produced by electric stations, factories, industrial equipment, and huge air vents. Some people believe the reason for the hum is the movements of tectonic plates and the Earth's crust under the ocean waters. But no one has managed to prove it yet. In most cases, people hear the hum in big cities, and, of course, they often complain about this and demand to conduct investigations. But all the attempts to find the source of this noise haven't given any results. It's possible that 4% of people have a unique hearing that catches low-frequency sound waves. One theory says the source of the hum is special radio signals. They're used around the world to communicate with submarines. These radio signals can make people have a response. It feels as if you hear some buzzing. This happens when radiant energy collides with the soft tissues of the human skull. It stimulates the auditory nerve and creates an auditory hallucination. But the coolest theory appeared in the city of Sausalito in California. A lot of people there hear the hum, and biologists believe that fish might be the reason. There are many toadfish on the west coast. They can produce a unique sound that is not audible itself, but the sound wave coming from the fish resonates with the buildings located near the coast. This resonance produces the hum. Even one fish can do this. Imagine what happens when thousands of these sea creatures scream at the same time. But not only people living near the shore have problems with the noise. Those who live in the city center hear the hum too. And since the sound waves created by the fish can't spread so far, the theory was quickly refuted. Our planet isn't the only humming one. In 2020, scientists recorded a strange buzzing sound on Mars. This is a quiet, long beeping that spreads across the red planet's surface. Sometimes it changes a bit because of Marsquakes, which are another mystery. Earthquakes occur on our planet because of the tectonic plates' movements. Stress accumulates and gets released in the crust. This produces earthquakes. But there's no plate tectonics on Mars, so Marsquakes aren't supposed to be happening there.
There are thousands of satellites flying around Earth. Some are needed to provide communication and GPS. Others monitor the weather and climate changes. In 2009, one of these satellites was circling our planet and scanning the waves reflected from the Earth's surface. The satellite was looking for changes in the emission of carbon dioxide coming from the planet, but it found something else. Something that completely changed the principle of studying the Earth's ecosystem. The source of the wave was utterly unknown. Scientists wanted to know the nature of these waves, so they tuned the satellite's instruments to the desired frequency and looked at the Earth. At that moment, they saw an unknown red glow surrounding our entire planet. In some places, the glow was weak, and while in others, it shone brightly. At first, everyone assumed that it was sunlight reflected from the Earth and produced unknown red particles. However, the analysis showed the glow's source was on our planet, and it never came from the sun's atmosphere. The glow may be the result of humanity, city lights, exhaust fumes, or something else. But again, scientists made a mistake. The brightest red light was radiated from places without humans. there were no traces of modern civilization. It turned out those places were swarming with plants. The brightest waves come from the Amazon jungle, croplands of the Midwestern U.S., northern evergreen forests, and other green areas. To understand the cause of the planetary red shining, scientists began to restudy plants. Every living tree, leaf, or blade of grass absorbs carbon dioxide and produces oxygen necessary for life. Plants manage to do it thanks to their ability to absorb sunlight. This process is called photosynthesis. New research showed that every plant emits a red glow during photosynthesis. It happens because they don't absorb all the incoming sunlight. They give part of it back in the form of a red glow, and this part is only 1% from all the receiving sunlight. This small amount of red light is impossible to see with the naked eye, but if you look at millions of plants from afar, the wave can be noticed. But still, with the help of special devices, this new photosynthesis process is called chlorophyll fluorescence. This is a hugely important discovery that allows people to monitor the state of nature. Previously, changing the color of trees helped us understand that something was wrong with the forests. For example, if a tree turns yellow, then it's probably not healthy, and we could observe the plant's state through satellites. But there are many exceptions to this method. In autumn, in many regions, almost all trees turn yellow and shed their leaves. But in any case, this monitoring system is not very effective. If we see an unhealthy tree because of its yellow leaves, then it's already too late to cure it. Any change in the red glow allows determining problems with the vegetation before the leaf color changes, and this helps to do something just in time. With the help of satellites, people can now see the problem areas of the planet. Also, the glow helps understand how much carbon dioxide and oxygen trees emit. We can learn about the plant's problem even before it occurs. The glow also comes from seaweed and phytoplankton. More than 50% of the oxygen in the atmosphere comes from oceans. Theoretically, it's possible to scan other planets in search of the red glow, to understand which of them has a habitable atmosphere. The red glow doesn't only come from our planet. In the depths of outer space, through a telescope, you can see the Horsehead Nebula, one of the most beautiful places in the universe. It's located in the constellation Orion. People called it so because of the similarity with the thrown-back head of a horse. This nebula was first discovered in 1888. This huge area of space is illuminated with a rich red color. This beautiful shining is possible because there are many super powerful blue stars inside the nebula. Their energy is absorbed by one of the most common substances in the universe, hydrogen. Hydrogen atoms receive such a strong charge from super powerful stars that they emit red light when they collide with electrons. Just imagine if a super powerful star was burning near our solar system, or if our planet was located in the Horsehead Nebula. Perhaps we wouldn't notice the red glow, so we would live inside this glow. We can observe beautiful multicolored nebulae only from the side, being thousands of light years away from it. Let's go back to our planet. By the way, there's another amazing glow surrounding Earth. It seems to be pulsating, shimmering with different colors, constantly changing its shape. If you look at our planet through special equipment, you will see that it's located inside this pulsating, uneven bubble. The bubble layer is quite thick. It covers the planet at an altitude of 50 to 400 miles above the surface. Even the International Space Station flies inside this glow. Almost all the satellites surrounding the Earth are in the zone too. It's called the ionosphere. It ensures the operation of communication and navigation systems. It helps radio signals and GPS to get to our mobile phones. The ionosphere is a layer of charged particles that separates the upper layers of the atmosphere from pure space. In simple words, this is a sort of an edge of our planet, the boundary between the place where we can breathe and the complete vacuum. Sunlight takes 1 or 2 electrons from the gases around the Earth, so these gases become charged particles. A huge accumulation of these floating particles creates the ionosphere. It's constantly changing its shape and size, as the planet is rotating around its axis and sunlight's falling unevenly. During the day, the ionosphere is always larger than during the night. Because of this, it looks pulsating and moving in different directions. This instability shortens the life of orbiting satellites and often puts them out of action, but it also helps to provide communication. Radio signals and GPS pass through it and reflect from charged particles and fly to our phones and navigation devices. Earth is not only glowing but also pulsating. An unknown pulse is coming from the surface or the depths of the planet. The pulsation repeats every 26 seconds and never stops. At some point, it's similar to a human heart. It's working almost in the center of the chest. Earth's pulse comes from the planet's center, the equator, but the exact location of the source is unknown. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, and scientists around the world still don't know the nature of this phenomenon. It seems as if our planet has a heart hidden inside the crust. According to research, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea called the Bight of Bonny. Every winter, the pulse increases, but then its strength weakens again. Scientists began to explore this place and put forward the theory that the ocean creates the pulse. Waves cross the surface and hit the continental shelf of the planet. This impact deforms the ocean floor. A strike to any flat surface works on the same principle. Hit any plate with a hammer, and you will feel a vibration through the object. The same beats are created by waves hitting the coastline. There are waves all over the world, not only at the equator. So why does microseism occur at the equator? Because in this place, the sun heats our planet the most. Solar energies increases storms and winds, accelerates ocean currents. Also, in 1980, geologists found out that microseism pulsates powerfully during storms when the waves hit the shore stronger. Not all scientists agree with this theory. Some researchers believe the planet is pulsating because of the seismic volcanic activity, and there's one that's located on one of the islands in the Bight of Bonny. The place of pulse origin is close to this volcano, but further observations have shown that microseism can be found in all places of the Gulf of Guinea. Scientists still can't prove any of the hypotheses. 84 million years ago, many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. And the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto. 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figured the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Ionosphere National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, They fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.